Hello everyone, thank you very much for joining me again with this episode where we continue our discussion on chapter 3 from Spring Start Here, a book which I wrote about 3 years ago. I have it here on paper copy and has even versions in other languages like the Korean one here. I hope and I really hope it's a good translation. I didn't try learning Korean yet to see. Anyway, let's continue with our discussion. If I correctly remember, last time we started already on chapter 3 and we started discussing on wiring beans. We discussed about how to wire the beans in the configuration class where they are defined with the @bean annotation. But remember, we talked from the very beginning that there is no a relationship between how you define the bean, how you add it to the context, and how you wire them. So you wire the beans in the same way regardless on how you created them up front, and you have those 3 ways to create the beans we have discussed in chapter 2, which is using the @bean annotation, using stereotype annotations, and programmatically via the register bean method in the context. If you're watching us live here, you have the live chat. Thank you very much for joining. You can put your questions, start discussions in the live chat. If you are not here live, you still have the comments section. And of course, you can follow me on LinkedIn and Twitter as well. So I hope to see as many as you there in the following period of time. Okay, so the discussion was around the @bean, and just to make a short recap, you remember that we discussed about the possibility of wiring the beans either by calling the method. So you had something like that, no person set parrot. I'm gonna actually answer a question because I wrote a question that I want to answer. So you can simply call the method like this and direct call, or you can define the parrot parameter, and then Spring will know how to inject the bean in the parameter, and this is what we started calling DI, dependency injection. And someone actually asked me which is my preferred way, because they seem to be the same, no? So you have this possibility of either putting the parameter here or simply just calling the method, no? So it's simply just calling the method like that. And up from our discussions, you hopefully understood that in terms of results, they are identical. So when you call it like that, if the bean already exists in the context, Spring will not create another one. This is really important to understand. So Spring will not create another one. We'll use the one from the context. Spring is a smart framework. It knows that these two define beans. It knows it because of the @bean annotation, and will be able to deduce that what you want here is not another instance newly created, but the one from the context, and it does exactly that. However, I do prefer to use the dependency injection annotation for a couple of reasons. So I do prefer to use this one instead of the direct call of the method. One is that if you have multiple configurations classes, you will anyway find it not really easy to just call directly the method. So this simply works if you have both methods in the same configuration classes. This is something to remember. I mean, calling directly the method. Secondly, another thing to remember is that this approach using the parameter is better also because it allows you to easier unit test the configuration method, which is something that we don't discuss now. We will discuss it much later only in chapter 15, which is the last chapter of the book. So this is where we discuss testing the Spring application. So all in all being said, to answer your question, I prefer to use the dependency injection even in this situation instead of directly calling the method, because I find it more generic and in the end, when I try to test the application, I find it more easy to do that with this approach rather than the other one. So I do recommend you use this approach with the dependency injection, which creates a more decoupled way. Now, going back to our chapter, we started the discussion on stereotype annotations. That's why I'm gonna clean this. And last question last time was whether you can use dependency injection in a class if you haven't used the stereotype annotations. And the answer, if you remember, was yes, you can do that, because, and I bolded that, I emphasized that very well, and that's a thing to remember. The way you define the bean is not related to the way in which you use the dependency injection, you wire the beans. So as long as they are beans, regardless that you've defined them as beans with the bean annotation, with the stereotype annotation, or with the register bean method, or even with XML talking about old scenarios, the dependency injection still works in all the possible ways, as long as it's a correct Java syntax, because there are some cases in which you cannot use the auto wire, but not because of Spring, because you end up with not a correct Java syntax, but that's another story. Okay, so what I mean here is that you have to treat independently the process of defining the bean with the process of wiring the bean. And you have already learned in chapter 2 how to define beans, and now you learn how to create the relationships among them, which is wiring, which is what we started called wiring. And in this case, for example, the two beans have been defined using the bean annotation, so both of them are beans, but they have been defined using @bean. But the wiring, the link between them has been done using the auto-wired annotation, which we said that you can use either on the field, and that's what we proved last time. We also discussed that this is not recommended, okay? And I'm gonna stress out a little bit more today why this is not recommended. So today we talk a little bit more about auto-wired and everything you need to know about auto-wired. You can put it on the setter. This is okay, but it usually creates a little bit more verbousness, which is not necessarily desired. Okay, so normally you can put it on the setter. Some would say, hey, this way I can add validations in the setter. Trust me, I've never seen this as being a good idea. So normally validations, if you need them, you can add them in different ways that we will discuss later. But the point is, if I put the auto-wired annotation over the setter, this will still work. And if I'm gonna run again this application now, let me run this again and see the result. It should be basically the same result. The only difference being that Spring, instead of directly injecting the value in the field via Java reflection, this time it will inject the value by calling the setter method that you have annotated. See, and the result is the same. So the result proves that the parrot has been injected, and it is indeed the parrot from the context, which is exactly what we expected. The difference is that if I would add a breakpoint here and I would try to debug instead of simply run this application, normally my IntelliJ should stop on this line, because again, the main difference between the field injection and the setter injection is that in case of the setter injection, the Spring will not actually inject the value in the field. It will inject the value in this parameter here, which then you decide in the setter what you do with it. Normally, of course, the setter, its purpose is to assign the value. Okay. Okay, so this is the point. Okay, and then I see a nice joke there. So the legend says that every time you use auto-wired, a unit test dies. But you know why that is? Actually, I will explain it. It only works with with Spring 5 and above. So this joke is only for Spring 5 and above, and I will explain you why. 5 or 4.3 or something. Anyway, it's not for all Spring versions. If you have an older Spring version, the joke doesn't work anymore. Why is that? Because again, and now we discussed about field injection, we discussed about setter injection. You have seen the result. Hopefully you have understood them, but this is not what you naturally use. So naturally you use the auto wired on the constructor. And how do you do that? Then you have to have a constructor that takes as a parameter those values that you want to inject, and then you can auto wire this on the class directly like that. Of course, in that this is that case that we discussed that will not work anymore with bean with defining the beans using the @bean notation. But remember what I told you at the beginning of this video. This is because it doesn't compile anymore. So not because Spring cares on how are the beans defined, but normally now you cannot define them with, you cannot define the person with @bean because it will need the parameter. So you cannot provide it unless you inject it also through the parameter here, which will be definitely an overhead which you don't want, and then it will anyway not be compatible anymore with the auto wired. So then what I'm going to do is I'm going to correct this by removing this bean definition from the configuration class, but I still have to make sure that person is a bean in the context, and I have only one other option that I can use in that case. So the only option to tell Spring that bean that the person is a bean, that person has to create a bean without needing to have upfront the value of the parameter to construct that bean, is to use a stereotype annotation. So this is the case where this will only work, so that the dependency injection via constructor will only work when the class is itself a bean defined using a stereotype annotation, either component, service, repository, or another combination. So it should be a stereotype annotation, otherwise it doesn't make sense. So now it again, not related to Spring, but it doesn't make sense in terms of Java syntax. No. Now if I'm running this, it's the same thing. So you have now a person bean because of the @component annotation, and you have a parrot bean because the parrot bean still is defined using the @bean annotation here. We need to make sure that we have the component scan in place, making sure that the person class is scanned, otherwise the @component annotation would not be found, which would make it not create a bean in the context. But since all of these are right, normally if I'm running again the application, it should show the exactly same thing. So you should see that the parrot bean from the context becomes referred from the person, and this line of truth here proves that it's not any parrot, but it is indeed that parrot that you can take from the context. So it's the same reference because we have compared it using the equality operator, which on objects compares the references in the memory. That's how Java works. Normally that's something we know. But going back, I will tell you now to answer the joke from George, is that in later Spring versions, it's not mandatory anymore. You use the auto-wire annotation when you have only one constructor in the class, and that constructor is made for for all the fields that need to be injected. So in this case, like this one I have here, because I only have one constructor, Spring will assume that the thing I want to do is inject the value in its parameters. That's how it works. Version 4.3 or 5 and above, okay? So normally that means that I'm still using auto wiring, just that the syntax, the Spring syntax became a little bit less verbose, allowing you to assume, because in the majority of the cases that was happening, now it's assumed that this is the way to work. So if you are working on an older Spring version, you might still see the auto-wired annotation used above the constructor, but in the most cases nowadays you don't even have to use it. And that is excellent also because, and you will see that later, I'm not gonna complicate my examples now, being still at only chapter 3, but for those of you who prefer using Lombok as a dependency to minimize the verbosity of their beans, Lombok, you use one annotation over the class, and then, for example, if you want getters and setters, you just define getter setter. If you want the constructor, you just define all args constructor or required args constructor or whatever constructor you need. And then the point is, in that case, you don't have the constructor actually written, so you can't add the auto-wire annotation. But that's not a problem, because with newer versions, just because you don't need the annotation, you can actually out of the box use this with Lombok, and then you don't even have to see, and the class becomes a lot simpler. Now I can prove this to you if you want, but I need to search for the Lombok dependency on the Maven, because I don't know it by heart. So let me try to do this. Let me see if I can find it. Okay, I just took it directly from Lombok site here, so it should be something like that. I put it here. So I know there is a debate on using Lombok or not. I don't say in this video that you should use it or not. It's your decision if you want. I'm just proving how Spring works, okay? So I don't want to debate on that. In case you wanted to ask me the question, I'm using Lombok, but I don't want to debate on that. So if you don't like it, don't use it. Point is, normally I can even do like that. No, I can go here, say, I will put like that, all args constructor, and then just to make things simple, I'm gonna make it have only one parameter, because then we complicate the things, and I don't want to complicate. So imagine this. I'm just gonna define like that, say getter and setter, okay? Preferably avoid using @data. I'm not gonna talk now about it, but preferably do that. And see, you now have the person definition. You've used the Lombok annotations, and it still works, no? Because even if you don't see the constructor anymore, since the newest Spring versions allow you to avoid defining the auto-wired, okay, it will still work. So while this is compiling, do you have a Lombok tutorial? No, but I can create one. I mean, Lombok is not that difficult in the end. In my opinion, you shouldn't actually even use all these capabilities, because sometimes it becomes too complicated. I'm usually relying mainly on all args constructor, no args constructor, required args constructor, getter, setter to string, and builder, and that's it. So if you know these annotations, from my point of view, it's everything you need, okay? So see, it's working. You can see in the console here, it works exactly the same, but I was able to simply just define this, because again, you don't need, so as long as you don't need write the auto-wired, and Lombok gives you the constructor. Here is how many developers prefer to write things nowadays, just because it's easier. And then the reason, actually, I'm gonna go back to the syntax without Lombok, because I want you to see the things. Okay, so I'm gonna redefine the constructor and the getters and the setters. And let's step a little bit away from Lombok, because it's not the target of our discussion. It's not our objective. I want to take a look at the Java syntax itself, because before using Lombok, I want to know that developers know the syntax that Lombok hides. This is the syntax that Lombok hides, or at least the way I've earlier defined it. Point is, one of the things, besides the fact that you don't need to write the auto-wired at all, you can now define this parameter as final. And of course, if you define it as final, setters don't make sense anymore, because it's finally makes it constant. But the point is that this is creating an immutable bean, no? So this way, someone knows that once you have assigned a value, a reference object value in this attribute of the person, you cannot change it anymore throughout the executions of its behavior, which is really important. This is a really good pattern that helps you minimize issues. So it's a best practice in terms of clean coding that we use mainly with all the beans, or most of the beans we create with Spring. And this approach with the injection on the constructor, and remember, this is still injection on the constructor, even if you didn't write the auto wired here, because you can because Spring allows you to skip it. This is still dependency injection, because what happens is, when this person being annotated as a component, when the class is scanned by Spring has to create a bean. It will see it has this constructor, and this is the only one, and then it will parse all these parameters. And what it does, it tries to find for each parameter a reference in its context. So if there is already a reference in the context, we'll inject it in that parameter. If there isn't a reference in the context, then it tries to find the class and create that instance. If it cannot find the class and there is no reference in the context already, it will fail with an exception. That exception that we have already seen in the previous episodes, where we discussed the creation of the beans, mainly the ones in chapter number 2. So point is, there are two things. One, you can skip the auto-wire completely, which, in case you use generated code with dependencies like Lombok, will allow you use those annotations to eliminate part of the verbosity of the code. And secondly, you can create this immutable. Moreover, a third advantage is that now you can easily create mocks for the parrot whenever you would like to test the person class. This is something we cannot discuss now. Not that we cannot, but we want to focus chapter by chapter on the book, and I have explained you already that testing, unit and integration testing, is something that we discussed in chapter 15. So that's where we are going to discuss the testing itself. But point is, this is also an excellent approach for writing unit tests, because it allows you to mock a parameter without needing Spring at all, which implies that you will be able to write tests that are completely detached from the framework. So you will be able to write tests to test your own code, so that you know how the code works before some framework, Spring in this case, before Spring controls it via the inversion of control principle, the way we discussed it. Okay, so That's going back to the joke. The legend says that every time you use auto-wired, a unit test dies. This is why. Because in the latest version, normally you don't use it auto-wired at all because the injection is made through the constructor. So that, and now you know why auto-wired disappears completely. And secondly, when you use auto-wired, if you use auto-wired on the field, for example, or on the setter, then the point is that you can only go through integration tests with Spring. You cannot go easily anymore to unit tests. So that's why it says that the unit test dies, because it's difficult to write a unit test in that case. But I will take again the joke and I will repeat it and explain the case better also when we reach chapter 15, where we discuss in details how to write unit tests. Good. And now this is basically, let's go back to the book now. So we discussed about the 3 points: injecting the value in the field directly, inject it through the setter, and the most encountered scenario, injecting it through the parameter of the constructor, where you remember that you don't need anymore, you don't need it anymore. So now if we go a little bit back on the book, I'm gonna just go through the code snippets and drawings just to show that this is exactly what we have already discussed. See, so we discussed the dependency injection through the field, and then we discussed about the impossibility, the impossibility of using auto-wired on a final field. I think this is something we ended up with last time, because that's why, hey, I cannot make it final and use auto-wired at the same time. So this is something that you don't have this option. No, it's written here. You don't have this option to do that. So this is something that it doesn't work. No, this doesn't compile. You cannot define a final field without an initial value due to, of course, Java syntax, basic Java syntax that you know. So then the question is, how do we do in that case? And the answer is, and you have already seen it in my code, you go with auto-wired on the constructor. And this auto-wired on the constructor, the word I put it here because it's important to still understand as the same behind the scenes. The only reason you don't use the auto-wired, or it's optional now, you can put it there, it will work, just that it doesn't make a difference. Or you are forced to use it only in the very rarely situation where you have multiple constructors in the class, and then you need a way to tell Spring which is the constructor out of multiple, otherwise it wouldn't know. But in the vast majority of cases, when you define beans, you only have one constructor, and in that case you don't have to use this. It's not mandatory, it's optional to use the annotation anymore. However, it still stays. You can this way tell Spring, hey, whenever you create that person instance, because I asked you through the component annotation to do that, inject the value of the parrot from the context and use it this way at the bean creation, at the instance creation. So that's exactly what Spring does. When it finds that component, it knows it has to create the bean in the context. So it calls the constructor because it needs to create the instance that finally it will add to the context. But then it observes that the constructor has parameters. So for every parameter, it will try to find a bean for it. If it doesn't find a bean for either of the parameters, it will fail with an exception. If there is, however, a bean that Spring can use, we'll inject the reference of that bean, and then depending on what you write in the instruction block of the constructor, that instance will be used somehow. Usually when we do something like that, we have simple assignments, so we don't, and it's not even recommended to have complex logic in constructors. No, if you need something like that, like some kind of logic, it is recommended to decouple it using the post construct method. We discussed also the post construct somewhere in chapter 2 when we discussed chapter 2. And that's it. Okay, fine. So then you see the example here where I made it final and we proved that it works. So one of the biggest advantages with the constructor is that it allows okay, starting from 4.3. So now I'm answering myself the question. It was not 5. Say starting with version 4.3, you can omit the auto-wired annotation. Okay. So nowadays we don't write it anymore, as I have proved even with Lombok. So have I discussed ACLs in Spring Security in action? No, I don't remember to have discussed it. I'm not even sure if ACLs are still something. I mean, as far as I remember, they might be or have been already deprecated, but let's talk that in another discussion because it's interfering with the subject of today's video. And then of course the proof of auto-wired, and I didn't want in the book to spend too much time with the auto-wired on the setter and on the field, because again, in terms of how practical this is, where I told you I do recommend use the constructor, and I want you to know that this exists. I want you to know that you have this possibility, but take it as, hey, it's nice to know, but not necessarily something that you will use. And then a very important subject discussed in this section 3.3 of the book is dealing with circular dependencies. So what you will observe is that you might create the way now Spring allows you to define the beans and auto wiring them will also drive you into situations where you create these kinds of dependencies where that create, let's call them deadlocks. They are very similar to thread deadlocks. No, in order to create a bean, you need another bean, but in order to create that other bean, you need the first one. So that's what we call a circular dependency. And trust me, I don't think there is any experienced Spring developer that hasn't encountered a circular dependency at least once in their life. So that's why it's important to understand circular dependencies and to know what causes them. And of course, knowing what causes them, you will be able to find a solution for your case. I say for your case because now in this example I took the simplest case, where you have two beans, one depending on another. But remember that this can be an entire chain, like bean A depends on B, bean B depends on C, bean C depends on D, and bean D depends on A. So it can be an entire chain that causes the dependency. So depending on how many beans are affected, the complexity of the problem might be higher or lower. But if you understand the codes, that now normally you will know how to refactor your code such that you eliminate the circular dependency. And what the circular dependency usually shows is an unclean, a dirty design of your code base. Usually it's what it shows, it's triggering, it's ringing a bell. Hey, you have a wrong design here. And I will tell you, because there are several ways in which you can solve circular dependencies, but usually the only correct way to solve the circular dependency is to refactor the code. To make it to decouple those beans in such a way in which they don't depend circularly from one to another. How many episodes do I plan? I don't know. I will finish when I finish the book. So I'm going through the whole book. But as you can see, the book has 15 chapters, but it takes me more than 1 hour usually to go through a chapter, depending on its complexity. So it might be, and it will definitely be more than 15. Cool. Let's explain this circular dependency. Let's go through it. So you have now the parrot. In order to define the parrot, you need a person, because you can see here on the left side, so the person is now an attribute of the parrot, is the owner. Parrot, the owner of the parrot is a person, and we want to keep it. So what do? We auto wire it, okay, through the constructor. And then on the right side, you have the same definition of the person that needs a parrot as its attribute. So the person owns the parrot is owned by a person. However, because both wirings are done through the auto-wired annotation, whenever Spring will have to create a parrot, we'll try to look for a person, and then we'll see that the person doesn't exist yet. So it goes at the person and tries to create the person because it has yet component annotation. And then it observes that it needs a parrot. But the parrot doesn't yet exist because in order to create it, Spring stopped here because it needs the person. Spring is now in a deadlock because it cannot finish the creation of the parrot because it needs a person. And it cannot create the person because it needs a parrot. So this is the simplest example where you have two beans in a circular dependency. This circular dependency only appears when you force Spring to create the beans, so when you auto-wire through the constructor at the initialization. If you would have used field injection, this was not the case because Spring was able to create the instances, and it first creates the instances and then it injects the value. But be attentive, that doesn't mean that field injection is better, okay? Because again, when you have a circular dependency, it shows you a design issue. And that is why the real solution to a circular dependency is to correct the design, decoupling your beans in a way or another, which usually depends on your code base. So there is no recipe that I can give you. This is the way to do it regardless of the case, because it always depends case by case. So how do I know when the next lesson is? I usually publish it a few days in advance. I will try to keep them Mondays, unless something we encounter something, but normally I will try to schedule it in advance on my channel. So what you can do, friends, also you have that bell on the videos or something on the channel. You can click the bell so that you get a notification when something changes on my channel, when I post something. If you want to be closer to me, I would be glad to if you use the bell as well to get notified. So please do that, and you will be always notified of everything that I'm doing on this channel. Okay, so how do we solve it? Well, just to point it again, one solution is to make this auto-wire through field, and then the problem gets solved. But it's not solved actually. Remember that the circular dependency, in most cases, is a design issue. So the fact that you have used constructor injection is good, and the fact that you have discovered the circular dependency doesn't have to scare you. It means it's good. It means you found the problem. Once you find the problem, you can solve it. So it's always better to find the problem rather than not find it, because now you know it exists and you can solve it. So don't try to simply put it under the rug, because if you wipe it under the rug, you simply just apparently solve a problem, but you will get on different problems later, once and throughout time your application is growing. So trust me, when you have a circular dependency, just try to find how are those two beans related? Why do they need to relate to one another? Try to logically understand the dependency between those two beans. Of course, this is only a theoretical example. I cannot give you a solution here, mostly because it's only a parrot and the person theoretical example. Okay, but normally in a real world application, you have, I don't know, the management service depending on the accounting, I don't know, component, which depends on the other. So you know better what those two are, and you have to find out why. What was the need? Which method needs which and why? Because that's a wrong design. That's a wrong design at the class level. It's not a Spring problem. It's a class design problem. It's an object-oriented programming problem that you have to solve. Okay. So you take a look on how those beans, two or more, relate to one another. You understand why they need it. And let me tell you a secret. In most cases, in my experience, this happens simply because a developer was lazy. They needed to call a method from a bean, and they simply just injected that bean without trying to understand the responsibility of the class. You know, we have the solid principles, the OP patterns that we use. Now, usually it happens from time to time, and it happens to me as well. So I don't blame. No, I'm not pointing to anyone. It happens. I'm human, and I can be lazy, and sometimes I'm lazy, and I'm not. Let's say my brain stops thinking, and I'm just doing the stuff as quick as I can so that I can go out or have a beer. So it's understandable. In most cases, take a look at the case, because it usually happened that developer just injected a reference of a specific bean because they need to call a method. But when they injected the reference there, when they created a relationship, they didn't, for example, think about whether it is normal from the responsibility point of view, from the coupling. Is that coupling needed? Do we add more responsibilities? Remember all those things. That's things that we need to consider. Okay, and that's how you find the solution to the cyclic dependency usually. Okay. Good. So that's how you do it. So you don't use, there is don't take, there are different solutions. If you go on Stack Overflow, or even if you ask ChatGPT, be very careful, because sometimes it gives you solutions like add lazy here. I didn't even discuss, I'm not even sure if I'm discussing add lazy here. Let me see. I hope I'm not, because it's not something you want. But point is, if you add lazy here, I will explain maybe at some point, maybe when we discuss the bean scopes and lifecycle, because it's a little bit more related to chapter 5 than to this chapter. But point is, don't use add lazy here to solve a cyclic dependency. Add lazy here, it simply just tells Spring that it has to create first a specific bean and then inject the value later if it has it, or put it null if it's not. It will again apparently solve your problem, but it will not solve it. Remember what I'm saying when you find such a cyclic dependency. When you have a cyclic dependency, it's probably a design issue, and the design issue is what you have to solve. The cyclic dependency, it's only a consequence of the design issue. Okay. So, question is your book still relevant? It's from 2021, so it's still relevant today. I think I have answered this question starting from episode number 1. Probably you have just jumped to this episode 5. Yes, it is still very relevant. That's why I'm discussing it. think about that. Would I lose my time discussing this book now if it weren't relevant? So everything that we have discussed here is still very, very relevant, and I just proved it the past 5 chapters, no, with everything that we have discussed. What has changed since then? The Spring version, but it doesn't affect you because this is very basics. So it's everything that you see here will work in 99 of the cases, maybe even 100. I haven't checked, but it's almost all of them, even all with the same, in the same way I'm describing them here. And we will see up to the end if there is any, and up to the end of this stream if there is any change. But yes, it's still very relevant. And how long will this remain current? To be honest, I think this will remain current for a long time because it's fundamentals, and fundamentals don't change easily. So normally I will anyway create a second edition when it makes sense, and usually it makes sense when more than, I don't know, 20% of the book is outdated, but it's not the case yet. So you can trust me and read it and learn it, and this will help you a lot. And you can actually stay with me here and we talk together about it, no? Cool. So I think I made my point on cyclic dependencies. You can try it yourself. And because we have like last 15 minutes and only one more section, so then next time we will be able to go to chapter 4. Let's discuss quickly about choosing from multiple beans in the Spring context. Now, it's something that we have already discussed also a little bit, I think, a couple of episodes ago, when I have told you about the existence of this qualifier annotation. And you also remember that we have discussed that there is a situation where you cannot simply just get the value by its type, and regardless you are using this getBean method or injection in any of the ways we have discussed them in this chapter, if you have more than one object of that same type in the context, then you will get that exception that is where Spring tells you, hey, I don't know who you really want to get. And remember that we discussed about the @primary annotation. So one of the solutions, and the solution that we discussed in the past episodes was using @primary. @primary helps you to mark one of the beans as being the default one in case you don't specify. So if you have multiple, you can mark one of them as primary, and then whenever you don't specify, that primary will be the default. Spring will basically default to that primary, and you can use that primary. You can use it on the component class, or you can use it on the @bean method as well. So it works with any kind of bean registration. Even if you use it programmatically, you have a parameter where you can make it primary or not. So that was one of the solutions. But the second solution is to simply get it by name. And remember that we discussed also when we talked about definition that the name of the method becomes the name of the bean with @bean. The name of the class actually is the one which becomes the name of the bean when you use a class. But remember that using stereotype annotations, you cannot create more than one component, more than one bean of the same type. So this issue where you have multiple beans of the same type to choose is usually happening when you use @bean annotation. So you have an example here where now we have 2 parrots, and then you want to get one or the other. Now, in this case, you need to specify correctly the name, and Spring will work even if you have used it like that. But what I do recommend you strongly is that whenever you do something like this, you use this @qualifier annotation. So you see, this @qualifier works even when the name of the variable, field, or parameter is different than the one here. So for example, here parrot is different than parrot1 and parrot2. So without the qualifier annotation, this would not work because there is no bean in the context with the name parrot. And being that there are more than one, Spring will not know which of the one parrot1 or 2 you want. So what I recommend you in that case is use the qualifier annotation, but what I actually do recommend you is use that qualifier annotation in all the cases, because what happens usually with code elements like parameters or fields is that someone might refactor them by mistake, and then sometimes you introduce issues without understanding, without being aware that you do that. So the qualifier annotation is an excellent approach, is an excellent way of using, of telling Spring who you want to be injected out of multiple beans of the same type, and you should use it regardless of whether you use the correct name or not for the parameter. Another use of the qualifier is to give a name to the bean. I'm not sure that explained here in this chapter as well. Let's find out. Okay, so no, this is just giving you as an example use of qualifier, just to see that you can use it with all kinds of injections. So even the constructor, field, and setter injection that we have discussed earlier. There is one more thing that you can do with qualifier. Actually, there are two more things that you can do with qualifier, but one of them is described in chapter 4 here. So I'm gonna shut my mouth and tell you about it next time, because we anyway run up to the end of this video. One other thing that you can do is to name the beans themselves. But since we discuss the abstractions in next chapter, I do suggest that you that we take it at that time. And here it is. We have seen everything in this chapter now, and we can actually read the summary if you want. And then I'm gonna go see, waiting for publish book or microservices. Maybe I'm not sure. Are microservices still a thing? Like, a lot of people started to understand that microservices are not a silver bullet finally. So they make now mixes of modular monolith applications and microservices. So cool. Spring context is a place in the app's memory. Okay, this just to remind you from the previous. Know what Spring context is. It's where the instances that Spring can control are. And then when implementing an app, you need to refer from one object to another. So you need to make relationships, and you have multiple ways in which you can establish the relationships. So we discussed about using the direct reference by calling the method, using the parameter. At the start of this episode, I also told you why I prefer actually the parameter instead of the direct call of the method. Or you can use auto-wired either on the field, constructor, or setter. Also remember that the auto-wired annotation today, when you use it with the constructor, is not mandatory, so in many cases you don't see it. And we have seen today even how simple it is to avoid a lot of verbousness of code if you use something like Lombok. So when we inject a value either in a parameter or a field, we say that we use dependency injection, which is a technique supported by the inversion of control principle. If you create two beans depending on one another, you will run into a cyclic dependency. So we covered the cyclic dependency as well. And then when you need to choose from multiple beans, you either have to use primary or you have to use qualifier. Anyway, in a way or another, you have to tell Spring which is the bean you need. And that's it. So any questions we have? Is it in heap? I think you referred to in the app's memory here. So the question is difficult because remember that we are making here an assumption of simplicity. I told from the very beginning, you need to imagine that the apps context, Spring context is like a collection. But remember that it is a little bit more complex than that, so I just made it more simple for you. If it is in a heap or not, if there are objects, it's regardless of on how you manage things. Java has a very clear and simple approach. Anything that is defined in the execution of the method itself, so what you reserve locally as variables become part of stack and will be eliminated with every stack layer, while anything that is object will be in the heap. So yes, most likely your instances are in the heap in this case. But again, this is somehow unrelated, and if I correctly remember, I might even have a video out there on the memory itself. If not, leave me a message and I will try to create one. And with that being said, I'm happy to say that we finally finished also with chapter 3. So next time we continue with chapter 4 and we will discuss about the abstractions. You will find out how Spring is smart enough to know how to use contracts and interfaces, which is extremely helpful because, and you've probably learned that as well already, interfaces define contracts and allow us to decouple objects. So it's essential in many cases we use interfaces for abstractions and creation of contracts. And you will see how how much smart Spring is as a framework, knowing how to work with interfaces as well, and what should you know about that. But that's a lot, and we will discuss it in chapter number 4, which is the next chapter. Until then, thank you very much for joining. Have an excellent time for learning, and I'm waving goodbye.